So when actually I talked to Glenn about, I believe like 3 days or 4 days ago, when I realized that I have to do talk today, and I realized it was going to be a future vision, I got scared. Why did I say yes to this? I don't know if I have a vision. I barely know what's going on right now. So when finally I got to my slides yesterday night, I was very prepared. I realized that perhaps the temptation of going to the technology talk was too high, and I had to stay back and think more of me as a person and not me as a technologist. And I realized that the future is all about expectation. What do you expect from tomorrow? What do you expect from today? So this is why today I'm going to talk about expectation and hopefully not too much about technology. This is a mandatory slide for me because, of course, I need to talk about who is paying for this trip, even though I'm local. But actually, no, it is part of the talk. So ESnet, for those who don't know what it is a research and education network. ESnet is about 26 years old. We celebrated last year, 2 years ago, actually, 25th anniversary. What is ESnet really? It is a facility, a networking facility, which is funded by the Department of Energy, the Office of Science. And the goal, the only mission of the ESnet is to be the networking facility for the DOE labs and partners. Why, you may ask? Why did the government is paying for this? Well, I mean, it's very expensive to design, build, and run such a network. The reason is that the research community have needs that are not fulfilled by the commercial internet. And the needs are actually pretty simple. That has to do with how the science is evolving, and that's where it goes to the future. The way we have seen the trend in terms of science in the past decades is we have been moving from small instruments that people were running in their own labs to really big and expensive instruments that are being built in one place in the world and used by thousands and thousands of researchers around the world. So why does it change? It changes that we need to start sharing data for the science that are produced in one part and distribute it all around the world. To make the story way more interesting, the growth of science data is actually really big. It's way bigger than the growth of data on the internet. In fact, until I believe about 12, 15 months ago, the biggest growth of data being changed on the network was actually scientific data, even more than Wall Street data. That changed a few months ago, and now again, Wall Street data is the biggest. But the internet is way beyond. I have a graph, which I didn't put there, but that really shows the growth of data, and it's exponential. We are in trouble, even if you have a very fast network like this one. So now let's think about what big data means and what it means for everyday life. So you see on those two pictures, those are two very different pictures. Well, actually, no, they are the same pictures, exactly the same pictures. Those actually were taken, those are frames, of a really big stream of data, which is modelizing the beginning of the universe. This is actually talking of the cosmology data. So somewhere in the US, and actually the source of data was in Argonne in Chicago. And they have a really big data set. This big data set is being streamed across the country, and that was for supercomputing in 2011. And to the supercomputing floor when there was actually a farm of machines being able to do all the rendering. So the first experiment was actually using a stream of 10 gigabit per second. That sounds really big to you. I mean, at least if you compare to your average bandwidth in the US, which is miserable usually. But that's about actually 2,000 times faster than your average bandwidth on that side here. So this is the universe at 10 gig. Now we ran the same experiment, of course, it was a demonstration, with the same data set at 100 gig, which is 10 times more. So that's about 20,000 times faster than your average bandwidth. And that's the difference. You see, you go from an empty universe to a universe which is like full of lights, right? And the only difference here is resolution. Resolution means you have more data to send. And the difference is also, and that's the end of these two pictures, if you are a researcher And what you look is the picture on the left. Are you going to have the same ideas, the same creativity, the same thought if you're looking at the picture on the right? I probably don't think so. So now we're talking about science, and science is, of course, perhaps the future of humanity, but that doesn't necessarily drive the internet. However, the common users, we do have the same problem, in a different scale, granted, but the same sort of problem. Everybody knows what those two devices are, I think. This was the original iPod. Actually, that was not the original iPod. This one is color, but sort of. And on that iPod was great. You know, you could put it in your pocket. You could carry some pictures with you. You can show them. It had no streaming capability. The only sort of streaming capability it had was a little FM receiver, so you could listen to the radio, not stream. And that was, I would say, about 12 years ago, something like this. Now we have this new device, which basically does the same thing. You carry it with you. You have images. You may have movies now. You can still stream the radio, not using the FM, but streaming. But the big difference is the screen. I mean, it's a beautiful image. I don't think any of you would like to see even a picture on that device anymore. What changed? What changed besides the technology? What changed is our expectation. Now we want this. We do not want that anymore. And we need to provide the resources to be able to achieve this kind of expectations. So when we have a device, what do you think about the network? Well, the network is a community. You connect, and it just works. Right, it just works. I'm pretty sure all of us have experienced when it actually didn't work. So what does it really mean it just works? I mean, can you actually do this? Can we make actually the network be something that you can truly say, it actually just works, really? So we need to understand what it means, what we think working means. Well, it means, first of all, that we can scale. We can scale from the low-resolution pictures to very high-definition movies. We must be able to scale from one source to many destinations. Sometimes you want to share a movie with a lot of people. So it needs to be able to scale. It also needs to be predictable. We are human beings. If you click on something on your button, on your screen, you want to see something happening immediately. If you need to wait for 5 minutes to get some sort of feedback, you don't do it anymore. You forget about it. So it needs to be predictable. We need to have an idea when I want to send a file, a movie to my friend. I need to know it's going to take me 5 minutes, 10 minutes, but I want to know. I want to know. If I don't know, I don't even know if something wrong is going on. And in fact, reproducibility is actually quite important. I mean, you may think that if I know ahead of time how long something is going to take, that's good enough. No, it's not good enough. Because you may not want to do a particular task if you don't know it's going to take about the same time as before. I mean, we are people, so that means we like habits. We like knowing things, how things are going to do. So it needs to be reproducible. How is it now? So yes, I hope you don't understand what this is about. But I took actually this snapshot from yesterday night. Yes, I said that I was doing my slides. I guess I was doing something else. So this is actually one of my favorite sources for French news. It's a website. I mean, it's done by a French TV. And I live in San Francisco. So this is actually a pretty long distance website. And what's that? I mean, where's my content to start with? And I'm totally blaming the designer of the website to make it so ugly. But my content is right here. See, like this is my stream. This is my stream. But all of these things you can see there actually are, of course, advertisement, even if you don't understand what it means. But there's all advertisement. Each of those advertisement is actually a movie. It's crazy, but it is a movie. Not even like an animation. You know, it's actually a stream. Even worse, several times on the same screen, you have the same stream going on because I don't know why they think like putting like 3 times the same advertisement works. I didn't want, because I don't want to get too frustrated, I didn't want to see how the website was built, but I would even believe that those are actually really 3 different streams. So what really happens when I do this? I click on this button here to play, and I see the usual buffering, I see a few frames, and then it stops again. very frustrating. I do have actually pretty good connection at home, not the average one. So I'm not happy about that. But what I can see now is, well, my advertisement looks great. Cool. This is not why I want this. So what is really happening here? I mean, what is happening? You have all those different contents that your browser is streaming. Your browser has no idea that what you care the most about is this. It doesn't know. Even if he knew, what could he do with that information? Probably not much. I mean, perhaps you could block some advertisement if you know if that's an advertisement, but he may not know. So what is happening? You have all those streams that compete on your connection, compete on your network resources to actually move all those bytes. And guess what? The competition is not that fun. So what is the expectation here? Best effort. That is what the internet is, best effort. Sometimes you can see the movies, sometimes you cannot. So I'm trying to summarize there a little bit. So why are we there? We are there actually because the internet is very robust. I mean, all of what I've just said, why the expectation is best effort, and actually it's not that great, it's actually a good thing. That is what is making the internet work, and still work with the growth that we have seen in the past 10 or 20 years. That's incredible that it's still working. And it's working because a lot of policies was made, a decision was made in the internet, in the protocols themselves. First one is what what is the expectation you should really have is your data is eventually to make it to the other side. It's gonna work. You don't know when, but it's going to work. So it's fairness. That means all your flows are going to make it through, independently in which one is it. It is actually neutral in a sense. Internet is neutral in a sense. It will not do anything special besides routing if you're coming from a place versus another one, or if your flow goes to a direction another one. It will make decisions in terms of routing because the bytes needs to go to the right destination. But that's it. It won't say, oh, this is coming from this particular device, therefore I'm going to do this. No, it's not going to do that. That's network neutrality. And that's a good thing, perhaps. But the last point also is the reason the internet is really working besides having protocols that are actually pretty solid, it's because there has a lot, dozens of thousands of people who are working 7 days a week and 24 hours a day to make that work. And that is actually a really, really big work. I'm not a network engineer, so I can talk about it because I'm just looking at them. That means those people really are not sleeping at night. Seriously, because they're afraid, but because they're constantly fixing problems. They're constantly reconfiguring things, talking to their peer to their network so things can work. So those are the three things right now which at the same time make the internet work, but at the same time perhaps we are not in sync in terms of what are the expectations. So now my question for all of us, and that was actually my own initial question, is it what we want for the future? Is it sufficient to have those kind of expectations for the future? And I would say no, I'm not happy with that, because again, I want to see my movie, I don't want to see the advertisement. So let's go back to the RNA networks, because in a way, that's what we did. We had to address, we were funded to actually address these kind of questions. So what did we do to do that? How do we actually make this picture happen? The 100 gig picture happen. And the first thing we had to realize was, well, in RNA networks, not all flows are the same. We have what we call the big elephant flows. This would definitely qualify as a big elephant flow. 100 gig flow is big. So we have those flows that are really, really big. And if you don't do anything special with those big flows, number one, will be interfered with the smaller flows. So bytes will actually not go through or not through fast enough to make it work. But something else also, those big flows are also going to interfere with the small flows. And at the end of the day, basically nobody is happy. So one way we have addressed this was actually exactly this, to distinguish between the flows. What you see on the blue line, on blue graph there, and don't worry about the units, I mean, those are actually gigabit per second. The blue line is actually the aggregate, the total traffic. The green line underneath is actually the traffic which is segregated. Those are the big flows. Those the traffic actually are being treated specifically by the network, by traffic engineering. So you see, actually, it's a good proportion. So right now, the latest measurement is actually about 60% of the entire ESnet traffic is actually on virtual circuit, which is the technology we are using. It's basically specific handling of the flows. So I'm sure many of you have heard many times that the internet must be fair, must be neutral, and actually, to be honest with you, I love those words. I want to be treated fairly and with neutrality. That makes sense. But are we really doing the right thing here? The internet is fair and neutral to the data. The network is agnostic. It doesn't know what the data is. Is it really what we need? And I'm saying no. That's not what we need. What you need to do is to have the network to be fair to the user and to the application. That's what we care. And in fact, perhaps what we want is to make sure that the network is not fair for the data itself. So why? Because like I just explained, different data flows may have specific needs a specific behavior of the network. That can go perhaps by using different set of protocols. Talk earlier mentioned the fact that perhaps IP is not right. In fact, we have been using for non-IP networks at ESnet for a while now. So that's true. Some flows may need different protocols. Devices are very different. I mean, of course, we have iPhones, laptops. They are all different kind of devices. And I would imagine that a Wi-Fi device doesn't have the same need as a wired device. I would go even further. Perhaps your device is not even running on a power. It might be running on a battery. That has a different need as well. We will not run the same protocols. We will not do the same thing if you're on a battery, because you cannot have the same power to power your CPU. And finally, as we have more services, we have more usage of the network, we are starting to use it more. I mean, I'm streaming my movies, again, from the network, and I'm paying like a flat fee, some services. However, this doesn't scale. What if the internet now has 10 different Netflixes? It won't work unless we need to have an economical model to those particular flows that you want to have a special treatment. So we need to have a way to not only say this flow is going to have this sort of behavior, but I want to be able to pay for it, because if I don't pay for it, I will not get it. I mean, I wish I could get it for free, but it doesn't work. So what all of this means? What does it mean to say that the network needs to start to be fair and neutral to the application? That really means that the application needs to cooperate, needs to collaborate to the policy making of the network. In other words, we cannot just treat the network as a black box anymore. So I did steal this sentence because I really liked it. So basically, a software-defined network is three different abstractions: distribution, forwarding, and configuration. Distribution is because networking, by essence, is a distributed problem. It's not just a one-to-one issue. It's actually much more than that. Think about when you manage your cloud, and when you use your slice on the cloud, well, your cloud may have a backup somewhere. So you see, even if you don't see necessarily all the distribution, it is a distributed problem. It is about forwarding data as well, because nowadays, you're not just consuming data. You're going to consume data, process them, and send them back. You receive a picture from a friend. You may add something and post it onto Facebook. So you're forwarding data. And it is about configuration, because if you want to have a different behavior of your flows, at some point, you need to tell the network to do it differently. So at ESnet, we've been working a little bit on this thing and we have starting to realize if you want to give some sort of control to an application, you need to provide the right abstraction. And here, I'm using the word abstraction, not API, intentionally. Because it's one thing to say that you provide a very rich API, but if you really want the application to use it, it needs to be an API that is usable by the application. That must be something, the concept, the abstraction is something that actually a software engineer can figure out and use. And this abstraction needs to be working for both layers. So we need to be able, what this abstraction should be. It should be able to express a desired behavior. I mean, I want this kind of protocol, I want this kind of quality of services. I must be able to predict the behavior and reproduce it. So basically, it needs to be a slice. I mean, it's all about network virtualization. I need to be able to provision a slice and use it. That's how I get predictability and reproducibility. And of course, these slides must be able to scale on demand. I must be able to say, well, actually, right now, I want more bandwidth, or I need another endpoint, or these kind of things. So when I was thinking about all of that, I was thinking, well, this kind of work happened before. I'm lucky enough to be old, in the sense that I remember a world when I started to program, where actually I had to use different API, system API, if I wanted to open a file written in Pascal, or if I wanted to open a file which was written in PL1. That was crazy. As a result, there was no text editor written. I mean, none of them which was like good, because who actually spend time to write a good text editor if you need to rewrite it completely just because you're opening different type of file? That doesn't make sense. And that was the world. Everybody had different operating systems. Everybody was happy until Unix came in. And what the people at Unix did, beside a lot of different smart things, but they came up with a very simple abstraction, which was the file. And what was a file? Well, the file was a file, for sure. But a file was also a device, a driver. A file was memory. A file was a socket, a network. Everything is a file. Every single in Unix, every single object can be represented and is represented by a file. And a file has a very simple API. You can open, read, write, close, basically. And guess what? That created an explosion of software. People were finally able to write software once and running at different places with not too much modification. So when I got there, it's like, what would be the file equivalent for the network? And well, I went for the simplicity. What is the abstraction that everybody knows nowadays? It's network abstraction. That's a network switch. That's a hub. Everybody has one at home. I even think that my parents know it now. It's not even funny. Because everybody does know. So this abstraction is a switch. If you provide a switch, simple switch abstraction to, yes, 5 minutes. I'm going to go fast. So if you provide a simple abstraction as a switch to the application, and if you can make this switch programmable, perhaps we're getting somewhere, because software will always see the same thing. So I'm going to skip a little bit those technical slides to go to this one. So now it's an abstraction. An abstraction is good only if you can actually implement it. And so that's the work we're doing in the test bed. We are building using existing protocol and APIs. We are basically saying that you have the physical layer. I mean, at some point, bytes needs to go on fiber, right? On this layer, the network operators, using a standard API called Network Service Interface, NSI, provision the network for you. This is actually how you provision a slice. And the way you provision a slice is you have to pay for it at some point, or even if you don't pay, you need to be allowed to use it. So the people actually doing this allocation, this reservation, might not be the end user. That might be your service provider. And they're using this kind of APIs. So basically, the various domains actually can collaborate and do that in a sense that actually works. But the most important part is actually on the top, where providing this single switch abstraction and making it this virtual switch, an open flow switch itself. There's no northbound API here. The abstraction is just standard open flow. We can perhaps program now the browser to be smarter and say that for this little advertisement there, I will just drop it. Or perhaps I will change the quality of services to make it slow, whatever. But now we can give the intelligence to this application to actually do all the control. And this is my last slide. So what we need to do here, what is the takeaway from what I tried to say, is the network right now has been trying, the internet right now has been trying to just survive, to just work the way it can, the best it can. And by still trying to be fair and neutral, because that's one of the buzzwords. It's hard to do it. It's even becoming harder. And I said I was not going to talk about IPv6, but in the context of migration to IPv6, this is going to be even harder. But perhaps we don't need that. Perhaps it's not exactly what we need anyway. We need new network abstraction, because we need the software to be able to be written for once and being able to not only be deployed in different networks, being able to optimize the network at the same time. But again, abstraction, in my opinion, is very critical because it will reflect the expectation that we need. And if we cannot express the expectation as a user we need, we should not expect the network to do it right. Thank you. Questions?
We have a couple questions. Here's one.
I'm wondering whether, to a certain extent, there's an economic argument against the trend of data capable, data-aware selectivity, given that in the example you showed there, the provider obviously wants to sell the ads. And if you have the ability to block the ads, they don't have an economic model to and the existing model, of course, is not that the network is intelligent, but rather you can pay to become a premier member and avoid the ads, so they get their money that way. Right. And that's been the workaround. In research networks, we don't have that problem. But in commodity networks, or the internet of the future, which will maybe marry the two together, do we need to have a different economic policy over the way internet data gets used and delivered in order to make this a viable approach in the economics?
This is a good question, because actually I did wonder myself when I did write this slide. First of all, no, research and education networks do, in a way, have the same problem, because some research might be funded more than others. And sometimes the pipe is just that big. So you need to make sure that those very well funded are the flows that we have to make it through, do make it through. So there is not expressed the same way. But no, there's still constraints which are equivalent to that. Now to answer your question, I don't think the economical model will go forward anyway. And I understand that some are talking about is controversial in the sense that, yes, I'm suggesting that if you have enough money, you may have better network than if you have less money. But that's not really true. But now what I want to make sure is we empower the users, the service providers, including the advertisement providers, to have the correct tool to really adjust your end user experience. Because, you know, I don't have the slides yet, but if you cannot see the content, the real content you're looking through, you're not going to go back on that page again, and you're not going to look at the advertisement again. So it is also the economical, I think there will be a reason to actually let you privilege what the content you really want to see. So I think you know, that we're gonna, I don't know your answer, to be honest with you, but we need to have the tools for at least to express on it. And because at least if you need to pay, you want to make sure that you pay for what you want and not for what you don't need. There was another question there.
Yeah, I was just wanting to echo on that question, because I was pondering when looking at that presentation. But I think that the point is, and you addressed that, is the customization. So that the content providers, right, today can only push one type of data. But in the future, they may have multiple versions of that. They may give the low resolution first and then allow people to customize. And that may be monetized
into this trend.
Right.
I agree. But
Last question.
This is along the same lines, maybe a little broader level. Like, how do you decide what's fair among flows? How do you maintain net neutrality in a world that works so easily?
So that's a policy. I mean, we are talking about policy. I mean, there's a separate mechanism from policy. The mechanism is actually how you decide, how you apply your fairness. The policy is actually, in my opinion, must be driven by the application. Of course, it is driven, I'm saying like completely implemented. But it must be given enough, not hints, not more than hints, I would say, but like a direction to the network to actually say, this flow is the one I really care about. Perhaps there will be a coordination between the two policies, because perhaps the network says, you know what, you're not important enough for me, so I'm not going to do it. So that's no brokering resources, because here what you're really talking about is network resource allocation. And when you have two different entities, two different policies, the one on the network and one at home, how you resolve that is by dialogue between the two. One saying, I need that, and the other one says, this is what I can give you. So I think that's how it would work.
Great, thank you.